Getting ready for an incredible cosmic light show. Let's get to know the champion of light, Quasar 3C 273, located at the center of a gigantic elliptical galaxy 2.5 billion light-years from Earth in the constellation Virgo. This quasar has large-scale visible jets, which are about 200,000 light-years across. Such emission is believed to be created by the interaction of the central black hole and the accretion disk. As a result, this object has a brightness of more than 4 trillion times brighter than the Sun. So bright, sunglasses are not enough. Hold on tight, because we are about to enter some very hot territory, WR104. This star is considered very hot due to its classification as a Wolfram or Wolf-Rayet star. These stars are super hot stars with very high surface temperatures. WR104 has a surface temperature that reaches 45,000 degrees Celsius. This very hot temperature is caused by the star's core undergoing a very intense nuclear fusion process. This nuclear fusion produces tremendous energy, creating very high temperatures in the core of the star. Next, we will move on to the weight division of the universe. R136A1 is the largest star in terms of mass. This star is still in the Wolf-Rayet star family, just like the previous star. This star is located about 50 kiloparsecs away in a neighboring galaxy known as the Large Magellanic Cloud. This star is one of the highest mass and brightest stars known, with a mass 315 times that of the Sun and a luminosity of 8.7 million times that of the Sun. With such a large mass, this star can only live no more than 10 million years. Just like the star version of Dwayne Johnson, he has the strong star muscles. Get ready to feel small, because we are about to meet the colossal giants of the star world. Stephenson 218, red supergiant stars in the Stephenson 2-star cluster, which is 6,000 parsecs from Earth in the constellation Scutum. If Stephenson 218 were placed into the center of our solar system, it would engulf Saturn's orbit. This star has a radius of about 2150 times that of the Sun. If the Sun were a marble, Stephenson's 218 would have a radius more than twice the radius of the center circle of a football field. Buckle up, because we're about to travel to the far reaches of the universe to meet the star Earendel, who loves to be alone in the star realms. This star is also one of the oldest stars, only 900 million years old after the universe was born. Maybe this star is not there at this time. This star, recently discovered by the James Webb Space Telescope, is located 28 billion light-years from Earth, so far away that an ordinary letter would take more than the age of the universe to reach it. Turn down to mini-size friends. We're about to enter the territory of EBLM J0555-57Ab, the tiny superstar on the star scene. The radius of this star is only 8% of the radius of the Sun, about 59,000 kilometers, almost the same as Saturn, but 250 times more massive than Saturn. That's why it still has enough mass to carry out nuclear fusion reactions at its core. If this star had a slightly less mass, there wouldn't be enough pressure in its core to start nuclear fusion, and the star would be a dim brown dwarf. Brace yourself for a bone-chilling expedition to the Boomerang Nebula, the cosmic freezer of the universe. The Boomerang Nebula is far from Earth. It took 5,000 light-years to reach this nebula. The temperature of the Boomerang Nebula reaches -272 degrees Celsius, 1 degree Celsius above absolute zero, which is the lowest temperature that particles in the universe can reach. Even the temperature of the Boomerang Nebula is colder than the average temperature of the cosmic microwave background, which is only 2.73 degrees Celsius. Moving on from the coldest place in the universe, we will venture into the dark heart of the universe, the black hole Ton 618, the black hole heavyweight champion. Its diameter is about 390 billion kilometers. It would take roughly 90 solar systems lined end to end to match its diameter. This object shines with a luminosity of 4 times to the power of 40 watts, or as bright as 140 trillion suns. Scientists calculate that the mass of this black hole reaches 66 billion times the mass of the Sun. So massive that even the light felt a bit anxious around it. If we were talking about the biggest black hole, now give way to the biggest planet. Ogle 2016 BLG 1190 LIB. This planet has an unreasonable size for a planet. It is 13 times the mass of Jupiter, so large that scientists doubt it is a planet. Until now, this planet is still being debated whether it is a planet or just a brown dwarf star that does not have enough mass to carry out nuclear fusion reaction. IC 1101 is the largest galaxy ever discovered. This galaxy is known to have 100 trillion stars. For comparison, the number of stars in this galaxy is about 400 times the number of stars in the Milky Way galaxy. With that many stars, the mass of the IC 1101 galaxy is estimated at 2.5 quadrillion times the mass of the Sun, or 4,300 times more massive than our galaxy. Its diameter reaches 4 million light-years, more than the distance between Andromeda to the Milky Way galaxy. Numbers that big might make your head hot, but be prepared for even hotter. Kelt 9b, the colossal roaster of the universe. Kelt 9b is a gas giant that is 2.8 times as massive as Jupiter, but only half as dense. Scientists estimate the planet has a smaller radius, but the extreme radiation from its host star has caused the planet's atmosphere to expand like a balloon. With daytime temperatures reaching 4,400 degrees Celsius, Kelt 9b is a planet that is hotter than most stars. But its star, called Kelt 9, is even hotter, a blue star that would likely disintegrate the planet through evaporation. We are now on the edge of the observable universe to meet the galaxy CEERS 93316. This galaxy is reported to have a redshift of 16.4, which makes CEERS 93316 the earliest and most distant galaxy ever observed. This galaxy is also a candidate for the oldest galaxy ever discovered, aged 13.6 billion years, or only 200 million years after the birth of the universe. This galaxy, recently discovered by the James Webb Space Telescope, is located 35 billion light-years from Earth, so far away that even Superman would need a GTS to find it. Pack up and prepare thick jackets, because we are going to visit Ogle 2005 BLG 390 LAB, a planet with eternal winter. This planet is located 20,000 light-years from Earth. It has a mass 5.5 times that of Jupiter and is classified as a gas giant planet, which is larger than Jupiter. This planet has a very low temperature. It is estimated that the surface temperature of this planet ranges from -220 to -250 degrees Celsius, making it the planet with the lowest temperature ever found. This very cold temperature is caused by its great distance from its parent star, with a maximum distance of 4 astronomical units. This causes the radiation received by the planet is very limited. Let's turn back the cosmic clock and meet the ancestor of the stars, HD 140283, or also called Methuselah. This star is at least 13.66 billion years old, 150 million years after the universe was born. The star Methuselah is known to be old because this subgiant star is metal poor. In other words, it is made up mostly of hydrogen and helium, with very little iron. With such a composition, this star likely formed before the element iron became very common in the universe. Because in the early days of the universe, heavy elements like iron did not exist. Iron-containing stars form when old stars such as Methuselah explode in supernova. Finally, we arrived at the loneliest place in the universe, Eridanus supervoid. If you are an introvert, maybe this place is for you. The Eridanus supervoid is one of the biggest supervoids in the universe. Located about 3 billion light-years from Earth, in the constellation Eridanus. This void has a diameter of about 1 billion light-years. In this supervoid, there are less than 10,000 galaxies, of which this place should be home to at least 1 million galaxies. Some speculate that the supervoid Eridanus may be a manifestation of dark energy,